When a mixture of calcium benzoate and calcium acetate is dry distilled, the resulting compound is A. Acetophenone, B. Benzaldehyde, C. Benzophenone, and D. Acetaldehyde. Now, the formula for calcium benzoate is C6H5COO, C6H5COO plus combine Ca, and the formula for calcium acetate is plus CaOC double bond O CH3 O C double bond O CH3. So when these two mixtures are dry distilled, this whole compound gets formed as a separate product. These two combine to form a product which is known as acetophenone, which is 2C6H5C double bond O CH3 plus 2CaCO3. This forms 2CaCO3 and the resultant product is acetophenone. So here the correct answer is option A. On-reductive ozonolysis yields 6-oxoheptanol, 6-oxoheptanoic acid, 6-hydroxyheptanol, and 3-hydroxypentanol. Now, the compound is given here. Now, on ozonolysis, that means on reductive ozonolysis, the double bond of the carbon will break up to form a C and a CH group like this. Here double bond will break to find C double bond O and CH double bond O, and the rest of the formula will remain the same with the CH3. Now this formula is known as 6-oxoheptanol. So here the correct answer will be option A. Ketones are prepared by A. Clemenson's reduction, B. Cannizzaro reaction, C. Rosenmund's reduction, and D. Oppenauer's oxidation. Now, isopropyl alcohol, which is given by RCH ROH. Now this reacts in the presence of CH3 thrice Al, which is aluminium terbutoxide. So isopropyl alcohol in the presence of aluminium terbutoxide gives the rise for the formation of ketones. Now this reaction is known as Oppenauer's oxidation. So out of the four options, D is the correct answer. Benzaldehyde can be prepared by the oxidation of toluene by acidic KMnO4, B K2Cr2O7/H+, C CrO2Cl2, or D all of these. Now we know that toluene undergoes oxidation in the presence of CrO2Cl2 to form benzaldehyde, which on further oxidizing in the presence of acidic K2Cr2O7 or KMnO4 forms benzoic acid. This is known as Itard's reaction. Now, acidic KMnO4 and K2Cr2O7 oxidizes toluene into benzoic acid, but Cr2O2Cl2 oxidizes it to benzaldehyde. So here the correct answer is option C. Heating calcium acetate and calcium formate, the product formed is, here are the options. Now, calcium CH3COOCA, CH3COO, which is calcium formate, on heating with calcium acetate, which is given by CaOOCH. Now on dry distillation, 2CaCO3 will be formed and the rest will be all joined together. Sorry, this here. 2CaCO3 will be formed. So the product will be 2CaCO3 and 2CH3CHO. Therefore, here the correct answer is option B. Identify the product C in the series. Is it A CH3COH, B. CH3CH2NHOH, C. CH3CONH2, or D. CH3CHO. Now, CH3CN in the presence of Na and C2H5OH will give rise to CH3CH2NH2. This on further reaction, which HNO2 will result in the product CH3CH2OH, and which on further treatment with copper at 573 Kelvin will give rise to a product which is known as CH3CHO. Therefore, here the final product C will be CH3CHO, which is option D. Dry heating of calcium acetate gives A. acetaldehyde, B. ethane, C. acetic acid, or D. acetone. Now, calcium acetate is given by the formula CH3 C double bond O O Ca, CH3 C double bond O O. Now, on dry heating, one of the bond of the Ca will be formed like this. This will result to CaCO3. So this will break out to form CaCO3, and CH3C double bond O CH3 will give rise to the product known as acetone, CH3CO CH3, which is known as acetone. Therefore, on dry heating calcium acetate, acetone is formed. So the correct answer here is option D. Which one of the following compounds is prepared in the laboratory from benzene by a substitution reaction? A. Glyoxal, B. Cyclohexane, C. Acetophenone, or D. Hexabromocyclohexane. Now, benzene in the presence of CH3 COCl with the catalyst AlCl3 will undergo substitution reaction, that is, one H hydrogen atom of benzene will be replaced by CH3CO, and the hydrogen atom will combine with H with Cl to form hydrochloric acid. So the product form, this is known as acetophenone. Therefore, here the correct answer will be option C. End product in the following sequence of reaction is either A. acetic acid, B. isopropyl alcohol, C. acetone, or D. ethanol. Now, HC triple bond CH in the presence of 1% of HgSO4 and 20% of H2SO4 forms the product CH3CHO. The triple bond will break to form a single bond. Now, which on further in the presence of CH3MgX and H2O gives rise to a product CH3CHOHCH3, which on further on treatment of one oxygen, it will give rise to a product called CH3COCH3, which is acetone. Therefore, here the correct answer will be option C, acetone. Reaction of acetaldehyde with HCN followed by hydrolysis gives a compound which shows optical isomerism, B. geometrical isomerism, C. metamerism, and C. tautomerism. Now, acetaldehyde, the formula for acetaldehyde is CH3C double bond OH, which on treatment of which HCN, which is hydrogen cyanide, and followed by hydrolysis will give rise to a product which is known as acetaldehyde cyanohydrin, which is CH3COHHCN. This product is optically active, and it is also an optical isomerism. It also shows optical isomerism. Therefore, here the correct answer will be option A. Content is highest in A. acetone, B. acetophenone, C. acetic acid, or D. acetyl acetone. Now, when you look at acetyl acetone, acetyl acetone has the formula of CH3C double bond O CH2 C double bond O CH3. Now, this is acetyl acetone, which is in the keto form and has 24% enol. Now, which when forms in in the enolic form, it is formed by CH3CO triple double bond CH3 double bond O H and C. So here it is the enolic form and has 76% enolic form. Now it is highest in acetyl acetone because keto group is much better electron withdrawal group than any other group in the options. Therefore, here the correct answer will be option B, acetyl acetone. Option D. The reactions which is given here is called either A. Perkins reaction, B. Claisen-Schmitt's reaction, C. Esterification, or D. Transesterification. Now let's look at the reaction. What is happening? This is an hydroxyl C double bond O CH3 in the presence of methyl alcohol and a catalyst, an acid or a base OH minus, gives rise to CH3 C double bond O C2H5 plus CH3 OH. Now what is happening here? Now here alcohol is reacting with hydroxyl, and therefore the alkyl group of ester, which is this ester, is replaced by alcohol. Here CH3 is replaced by C2H5. Now this reaction is called as trans esterification reaction, and this reaction happens in the presence of an acid or a base group. Therefore, there the correct answer will be option D. Mixture of benzaldehyde and formaldehyde on heating with aqueous NaOH solution gives A. Benzyl alcohol and sodium formate, B. Sodium benzoate and a methyl alcohol, C. Sodium benzoate and sodium formate, or D. Benzyl alcohol and methyl alcohol. Now formaldehyde is given by C6H5OCHO plus formaldehyde, which is HCHO, in the presence of aqueous NaOH gives rise to C6H5CH2OH plus HCOO, which is benzyl alcohol and sodium formate. Therefore, here the correct answer will be option A. Cinnamic acid is formed when C6H5CHO condenses with CH3CO twice O in the presence of either A. Concentrated H2SO4, B. Sodium acetate, C. Sodium metal, or D. Anhydrous ZnCl2. Now C6H5CHO in the presence of plus C3CO twice O gives rise to cinnanoic acid, which is C6H5CH double bond CHCO2H. Now this happens in the presence of CH3CO2Na, which is known as sodium acetate. This reaction is known as Parkinson's reaction. Therefore, here the correct answer will be B. Sodium acetate. Which of the following compound is resistant to nucleophilic attack by hydroxyl ions? Either A. Methyl acetate, B. Acetone nitrile, C. Dimethyl ether, or D. Acetamide. Now if we look at option C. Dimethyl ether, given by CH3O CH3, here the electron density of oxygen is highly increased, therefore resistance to nucleophile attack is also increased. Therefore, if the electron density of oxygen is increased, then resistance to nucleophile attack also increases. Therefore, here the correct answer will be option C. The product formed by the reaction of chlorine with benzaldehyde in the absence of a catalyst is A. Chlorobenzene, B. Benzyl chloride, C. Benzoyl chloride, or D. Chlorobenzaldehyde. Now, benzaldehyde is given by the formula C6H5CHO in the presence of chlorine, which is Cl2, and without any catalyst gives rise to a product which is known as C6H5COCl plus HCl. This product is known as benzoyl chloride. Therefore, here the correct answer will be option C. Formaldehyde, when treated with KOH, gives methanol and potassium formate. The reaction is known as Perkins reaction, Claisen reaction, Cannizzaro reaction, or D. Knoevenagel reaction. Now, formaldehyde. Two formaldehydes are treated with KOH, so the product form will be methanol and potassium formate. Now here, one substance is oxidized and the other is actually reduced. So this type of reaction is known as Cannizzaro's reaction. Therefore, the correct answer here is option C, Cannizzaro's reaction. Compound obtained by the reduction of propanaldehyde by amalgamated zincs and concentrated HCl is A. Propanol, B. Propane, C. Propene, or D. All of these. Now, propanaldehyde is given by CH3, CH2, CH plus 4H in the presence of amalgamide zinc, which is ZnHg, and hydrochloric acids gives rise to a product which is CH3, CH2, CH3 plus H2O, which is propane. And this reaction is also known as Clemenson's reaction. So here the correct answer will be option B. Even reaction. Now the same reaction can take place with which of the following aldehydes? CH3CHO, CH3CH2CHO, CH3 3CCHO, or D CH3 2CHCHO. Now let's look at the reaction. 2C6H5CHO reacts with NaOH and gives rise to C6H5CH2OH plus C6H5COONA. Now this is known as Cannizzano's reaction taking place in aldehyde having no alpha hydrogen present. Therefore, if the aldehyde has no alpha hydrogen, this reaction can take place. Now, in the aldehyde given CH3 thrice CHO, there are no alpha hydrogen present. Therefore, this reaction can take place in CH3 CHO. Therefore, here the correct answer will be option B. Here the correct answer is option C. M-chlorobenzaldehyde on reaction with concentrated KOH at room temperature gives, here are the many options. Now M-chlorobenzaldehyde is given by Cl and CHO plus CHO in the presence of concentrated KOH gives rise to COOK, which is potassium M-chlorobenzoate plus CH3OH, which is alcohol, which is M-chlorobenzyl alcohol. Therefore, here the correct answer will be option D, potassium M-chlorobenzoate and M-chlorobenzyl alcohol. Treatment of propanaldehyde with dilute NaOH solution gives A. CH3CH2COO CH2CH2CH3, B. CH3CH2CHOH CH3 twice CHO, C. CH3CH2CHO CHOH CH2 CH2 CHO, or D. CH3CH2 CO CH2 CH2 CHO. Now propanaldehyde is given by the formula CH3CH2CHO plus CH3CH2CHO, where this is the alpha hydrogen atom. On reaction with dilute NaOH gives rise to the product which is CH3CH2CHOH CH3 CH4 CHO. Now this product, therefore here the correct answer will be option B. If formaldehyde and KOH are heated, then we get A. acetylene, B. methane, C. methyl alcohol, or D. ethyl formate. Now formaldehyde CHCHO plus HCHO is heated with KOH to give the compound HCOOK plus CH3OH, which is methyl alcohol. Therefore, here the correct answer is option C, methyl alcohol. Trichloroacetaldehyde was subjected to Cannizzalo's reaction by using an AOH. The mixture of the product contains sodium trichloroacetate ion and other compound. The other compound is, here are the options. Now, trichloroacetaldehyde is given by the formula Cl, C, Cl, Cl, C double bond O, H, which was subjected to Cannizzalo's reaction by using NaOH. Therefore, the product form was sodium trichloroacetate, which is Cl, C, Cl, Cl, C double bond O, O minus. And the next product was formed as Cl, C, Cl, Cl, CH2OH. Therefore, this product was known as 2,2,2 trichloro ethanol, since there was 3 chlorine atoms on one C and the product was ethane, which is ethanol. Therefore, the correct answer here is option A. Which of the following products is formed when benzaldehyde is treated with CH3MgBr and the additional product so obtained is subjected to acid hydrolysis? A. Secondary alcohol, B. A primary alcohol, C. Phenol, and D. Tert butyl alcohol. Now, benzaldehyde is given by C6H5CHO, which was benzaldehyde was subjected to CH3MgBr, and the addition product was subjected to acid hydrolysis, which is S plus H2O. Therefore, the product after these was formed as C6H5CHOH which is a second degree alcohol. Therefore, here the correct answer will be option A, secondary alcohol. Which of the following gives aldol condensation reaction? A. C6H5OH, B. C6H5 C double bond O C6H5, C. CH3CH2 C double bond O CH3, or D. CH3 twice C double bond O CH3. Now, aldol condensation happens when there is alpha hydrogen attached to a carbon atom. Now, although CH3, CH2, C double bond O, CH3, and CH3 thrice C double bond O, CH3, they both have alpha hydrogen attached to a carbon, yet CH3 C or CH3 does not undergo aldol condensation because of a steric hindrance. Therefore, here the correct answer will be option C, CH3 CHCCO CH3. Therefore, the correct answer here is option C. The following pairs is not correctly matched. The conversion of aldehydes to CH2, Kaminson's reduction, which is actually true. Kaminson's reaction actually converts the aldehydes into CH2. Now, COCl, Rosamond's reaction to CHO, is also true. D is also true, but however, B is not true. We'll take a look at this with example. An aldehyde in the presence of NH2 or KOH gives rise to an alkane plus N2. Therefore, this is known as Wolff-Kishner reduction. It reduces aldehydes to CH2. But however, here it is given as it reduces to CHOH. Therefore, this is wrong. Therefore, this is wrong. Therefore the correct answer is option B. Reduction of aldehyde to CH2 can be carried out with A. Catalytic reduction, B. NaC2H5OH, C. Wolff-Kishner reduction, or D. LiAlH4. Now, let's look at example. This is an aldehyde. This is an aldehyde which, under the reaction of NH2 or KOH, gives rise to an alkane plus N2. Here, an aldehyde group is converted into an alkane. This reaction is known as this reduction is known as Wolff-Kishner's reduction. Therefore, here the correct answer is option C. For C6H5CHO, which is benzaldehyde, which of the following is incorrect? An oxidation, it yields benzoic acid. It is used in perfumery. It is used as an aromatic aldehyde. And D, on reduction, yields a phenol. Now, the first option is actually correct. When benzaldehyde is treated, is oxidized, it actually forms a benzoic acid. So the first option is correct. The second and the third options are also correct, as as they are the properties of benzaldehyde. Now, however, the third option, when benzaldehyde is reduced, it gives rise to benzyl alcohol, which is CH2OH. Therefore, on reduction, it gives benzyl alcohol, not phenols. Therefore, option D is incorrect, which is the correct answer. Identify the reactant X and the product Y in the following reaction. Now, here are the different answers. Now, let's look at the reaction for once. CH3 CO CH3 reacts with the product X to give the answer as CH3 thrice COMgCl. Now here, what is happening? CH3 is becoming one more. There are two CH3 and one more CH3 is getting added. And an MgCl group is also getting added. So we can say that X is equal to CH3 MgCl. Because we get MgCl as well as one more CH3. Now on hydrolysis of the same, we get the answer as Y plus MgOHCl. Now what is happening here? CH3 thrice is getting away from here and MgOHCl is coming. So we know that the group which is getting added is the group has some kind of OH here. Since H2O, since this is hydrolysis, OH will come here. Now this is missing from the answer. Therefore, the answer will be CH3 3C, and since it is H2O, it will become OH. Therefore, X is equal to this and Y is equal to CH3 thrice C OH, which is option C. Ozonolysis of an organic compound gives formaldehyde as one of the products. This confirms the presence of A. Two ethylenic double bonds, B. a vinyl group, C. an isopropyl group, and D. an acetylene triple bond. Now let's look at some of the reaction. Now suppose the reaction is this, which on ozonolysis gives the formation of formaldehyde. Bond O, H plus O double bond CHR. Therefore, we can see from this reaction that the presence of one vinyl group gives formaldehyde as one of the product in ozonolysis. Therefore, here the correct answer is option B, of vinyl group.